Hi everyone, my name is Steven. I'm Protocol Cosplay, and today we're going to be talking about upgrades to Shadow RC, why we're doing it, and you'll hopefully see me perform one of those upgrades today. Let's get started.
Wait! Wait! Oh my! What have you done?
So why am I upgrading Shadow RC? Well, Shadow RC, if you don't know, is a control system that I made for R2-D2. The reason I made it was because I was having a lot of trouble actually attaching and getting my PS3 remotes to connect to the Arduino. Um, and I decided I'd rather go with an RC system and rewrite the code and make it my own. Basically, it's kind of like Shadow, but it's also an RC system. Well, Shadow RC runs on the Arduino Mega. Now, this is an Arduino Mega, like a regular one, but I have an ADK version in my R2. But if you have the regular version, generally you also attach one of these. This is just a USB host shield that you would place on top of the Arduino, and you would stick in a USB dongle, a Bluetooth USB dongle here, and you would use your PS3 remotes or Xbox 360 remote or something like that to control the functions on the Arduino. That wasn't working. So I got rid of this and I used my ADK and I basically made the Shadow RC system plug into these pins with their the signal wires and run it that way, which it has been working in some ways, but there's been some issues and parts of the code that kind of fail. And to be honest, this is just not a very good microcontroller these days. It's old, it's very old. It's bulky. It doesn't have as many like usable pins that you would want to use for things, and it's slow. So what are we going to do with the upgrade? Well, from this form factor, as big as this thing is, we're going to replace it with this. I mean, just look at the size difference. But we're going to replace it with this. Now, what is this? This is a Teensy 4.1. And when it comes to the comparison between this clock speed and processing power and this clock speed and processing power, this is like using a laptop, and this is like using like a laptop from like the 2000s, and this is like using an iMac. Like the power difference between these two things is insane. I think this runs at like 16 megahertz, and this one runs at 600 megahertz. So it's multiple times faster than the Arduino. It's also smaller, as you can see. It's basically the size of like a flash drive. So this is what we're going to ultimately use to control R2 moving forward. We don't need to go with these. These are actually hard to find, and they're slow. And while they're compatible with Shadow or Padawan 360, there really is no reason to not go with the Teensy if you can make the code work. And that's what I intend to do. So let's talk next about what we're going to do in terms of mounting this and getting this ready for R2's system. Okay, so we're going to be using the Teensy, and we want to attach this to something that's easy to hook up. Now you could probably mount, headers onto this and plug it in with DuPont connectors and stuff like that. I don't particularly like that. I like terminal connections because they're better in terms of reliability and all that. So what we're going to do is we're actually going to mount this to a custom PCB that I've made. So this is the custom PCB. It's going to have a little bit of a design change because I'm working on something else that's going to be interesting for this. But this is basically the V0 prototype, but it's going to have a slight design change, but it's more or less going to be this. And what this is going to do is it's going to mount the Teensy, It's going to mount terminal connections for the signal wires of the RC remotes. We're also going to add in 2 buttons that are going to be used for like headerless stuff. Things like if you want to change him into a different mode on Shadow RC, you can do that with the buttons that are on the PCB, in case your controllers die or something like that. And there will be some other functions with those buttons, but that's the main one. And then it'll have breakouts for other connections on the Teensy. And we're also going to eventually have it have the audio shield. I'll show you the audio shield in a little bit, but the audio shield from Teensy mounts on top of the board, and it allows for MP3 playback. So what this means is that you won't have to have, the Arduino and then also have the SparkFun MP3 player and trying to make sure that those work. It'll basically be in this form factor. This is the entire thing. It's his brains, it's his speech, it's everything. So the footprint is much, much smaller. So what we're going to do now is I'm going to get the camera a little bit closer, but we're going to start soldering the necessary components to this board, and we're going to make it basically a fully functioning prototype board, because I still have to work out the new code and basically take the Shadow RC code and make it work on the Teensy. But today what we're going to do is we're just going to make sure that this board is all good to go. We're going to solder on the connection points and everything else. One other thing I forgot to mention before we get into that is the Teensy runs on 5-volt power, but it runs on 3.3 volts logic. And what does that mean? Well, it means that it takes in 5 volts power to power itself. So you can plug in a USB connector to a wall adapter or to your computer or something like that, and that'll provide power. Or you can provide it to the pin, which I'm going to do. But the logic side is 3.3 volts. And that's pretty typical with new electronics these days, is that they want to run at a lower voltage for the signals and make them 3.3 volts rather than 5 volts. Well, the Arduino of old ran on 5 volts pretty much everything. It wanted 5 volts power, and it had 5 volts signals. And that's fine, and it actually worked pretty well for the controllers that we use in Shadow RC, because those controllers are also outputting 5-volt signals. They're powered by 5 volts, and they send 5-volt signals through their signal lines. Well, that's a problem for the Teensy, because if you put 5-volt power or 5-volt signal line into any one of these GPIO pins, and they're wanting 3 volts, well, they're going to either burn out or they're going to have a problem. Sorry. So what does that mean? We have to we can't change the voltage of the controller, and we can't change the operating voltage of the GPIO pins here to 5 volts. So what do? Well, we use what's called a level shifter. It's hard to see, but that is a level shifter. A level shifter is a tiny little board that will take in an incoming voltage, in this case 5 volts, and it will step it down to 3 volts. And what that means is that the signal can safely pass through this level shifter and get stepped down to 3 volts so that it doesn't burn out or mess with the Teensy. We have 12 channels here that we're going to be attaching to the Teensy, so we need 12 level shifted channels. This is a 4-channel one. It has a ground and a power line to it, because it has to know what the power is that's coming in and what's the power going out. So it has 4 channels on this, so we'll need 3 of these, and that will sit in between the connection of the signal line that you plug into the terminal connection, it'll sit between that and the Teensy. So that there's no possible way for you to accidentally put 5-volt power into the Teensy and blow out one of the pins. So we're going to attach those as well, and then we're going to see how this prototype comes out. So let's get to soldering. Okay, so after all that soldering, I took the initiative to just put it on the board. But basically, I've taken the Teensy with the stackable pin headers, and I've soldered it to the board and to the pin headers. So the pin headers are soldered to the Teensy, and then the Teensy is soldered down to the board. I'm going to clip the ends of this in a little bit, but the first thing I want to do next is attach the level shifters, which I need to solder down onto these pins. And then once that's all done, we'll solder on the little green terminal connectors for connections, and then we'll solder on the button, and then we'll be good to go. So let's get soldering on the level shifter. I'm not really going to show this on footage because it's going to be kind of boring, but yeah, we'll get this done and we'll see where we're at after those are soldered down. Okay, so now we've got the level shifters attached, and this basically means that we can safely step down the voltage between the receiver outputs to the Teensy. And now all we have to do is attach these little green terminal connections and make that work a little with the connections to the signal wires. And there's a couple of them that are longer than 4 pins. You can actually, put a number of pins on this, so should work out fine. And then we'll attach the buttons. So let me get those attached and I'll show you what that looks like. Okay, so I've gotten all the terminal blocks on here. Hopefully they're pretty solid. Again, this is a kind of a prototype, but kind of not. So we've got all the terminal blocks on. Now we have to put on the buttons, the little push buttons, and the power block, which is a different color so that you know which is the power and which is just signal wires. So once we've got that, we'll then clip all the excess height off of these pins, and then it'll be ready for testing. So let's get those last couple of components on and then we'll go from there. Okay, so now I've attached the power terminal connection, that's this blue one, and the 2 little push buttons, which will have some functionality to them. So now when you take a audio shield like this, which I've already soldered on the pins, and you attach it to the Teensy, lining up 5 volts and 5 volt on the Teensy, you will have this, and that is literally everything. This entire thing will run R2. It'll play his sounds. You don't need a SparkFun audio player or anything like that. It'll hold everything that you need and it'll do everything that you need. Compare that to the footprint of something like this, which is much bigger, and you still need a MP3 trigger board for that. And you can see there's no real competition. This is faster, better, and more reliable than that, but it also is more compact. So the next thing to do is to get the software going and make sure that ShadowRC can port over from where it was on the Arduino to the Teensy and change the pins and all that kind of stuff. And then we'll start testing. Once testing is done and I'm confident that it's going to work, we're going to do a run of these kinds of boards. So if you want a fully built out system that's basically plug and play turnkey, keep an eye out for the run. And then, yeah, and then hopefully we'll be able to get these into the hands of a lot of different people. So that is the video. I hope you enjoyed it, and wish me luck on the creation and the upgrade of Shadow RC. Catch you guys later.